Everybody, this is Mr. McNair, and this is our video on 4.3 and 4.4. 4.3 is the rate of change in slope, and 4.4 is the slope formula. So let's talk about this. Rate of change. Rate of change is a ratio that compares the amount of change in a dependent variable to the amount of change in the independent variable. I often like to think of rate of change also. I also like to think of it as the change in the y over the change in the x, or change in the dependent variable over the change in the independent variable. Okay? So let's take a look at an example. Example 1. In 1988, there were approximately 70 million walleye in Lake Erie. In 2000, there were approximately 21 million. What was the rate of change for the walleye population? All right, so the first thing that you want to do here is you want to look and see what is the change in the dependent variable and divide it by the change in the independent variable. So the dependent variable is the walleye population. So at the beginning, we had 70 million walleye, and then we're going to subtract from that 21 million walleye. Okay, so that's a total change of 49 million walleye. Now, specifically, we went down by 49 million, so this is going to be negative 49 million. And then we're going to talk about the change in the independent variable, which is the time. We started off in 1988, went to 2000. That was a change of 12 years. So if we divide that out, negative 49 million divided by 12, we get negative 4.08 million. Which is, if you wanted to, you could just say that's negative 4,080,000. So we were going down by approximately negative 4.8 million, 4.08 million per year. Okay, so that was our rate of change. All right, example 2. The table shows the balance of a bank account on different days of the month. Find the rate of change during each time interval. Then it says, during which time interval did the balance decrease at the greatest rate? Now, once again, we know that rate of change is the change in the dependent over the change in the independent. All right, so our dependent variable is our balance. And that's going to depend on the day it is. So that's our independent variable. All right. So I'll just say this is our dependent. This is our independent. So in the first time interval, from day 1 to day 6, how much money did we lose? Well, we went down by $265, and that was over a 5-day period. So if we take our change in our dependent, divide that by the change in our independent, we find that the change was $53, negative $53 per day. All right, so that was our first rate of change. Then we can keep on going. Here, we went down $75, and that was over a 10-day period. So once again, divide that out, we see that on that time interval, we went down $7.50 per day. Our next time interval, we didn't go down at all, and that was over a 6-day period. So that was $0 change per day. Let me change my color here. That was a $0 a day change. And then our last time interval, we went down from 210 to 175, so that went down $35 over an 8-day period. And that was a change of, excuse me, let me do my color again. So we went down $4 and approximately 38 cents per day. Okay? So there we go. We found the rate of change during each time interval. Now it says, during which time interval did the balance decrease at the greatest rate? Well, out of all of those, obviously, losing $53 a day is greater than losing any of those other amounts. Okay? Now, rate of change is the same thing as slope. However, slope is used specifically for lines. When I think of slope, I think of how slanted something is. Whoops, let's bring that back. Slope is how slanted something is. So these are all examples of slopes. Ski slopes, this hill is a slope, this ride right here, the Millennium Force. I love the Millennium Force. That's a slope. And then even this haircut that Bobby Brown had back in the day, that was sloped. All right. Now, here's our next section, 4.4. The variable used to represent slope is m. All right, there's a couple different slope formulas that I want you to know. The first formula has to do, once again, with the change in y over the change in x. And we know that that delta, the triangle, is a symbol that we use for change. Another formula, y2 minus y1 over x2 minus x1 is a formula for slope. And then we also use rise over run. Okay, notice that this first formula, once again, we said that rate of change is the same thing as slope, and that's pretty much the same formula that we used before. We said the change in the dependent, and y is our dependent variable, over the change in the independent, and x is our independent variable. All right, so this one, find the slope of the line. Now, it's probably easier to find the slope of this line by using our rise over our run. You could use your y2 minus y1 over x2 minus x1 by telling me, okay, well, this point is negative 4, 1. This point over here is 2, 4. But that's really not necessary. Okay? In a problem like this, just counting up and over is probably the quickest way. So to go from this point to this point, we had to go up 1, 2, 3. So our rise was 3. And then our run is 1, 2, 3, 4, 5, 6. So we went over 6. So the rise was up 3, the run was 6, and you always, always, always reduce your fractions. So that reduces down to a half. So the slope of that line is 1/2. Now I do want to point out that sometimes you don't necessarily have to go from the bottom point to the top point, from the point on the left to the point on the right. You could you could go in any order that you really wanted to. For example, let's say we started off at this point and then we went down to this point. Well, to go from here to here, we had to go down 1, 2, 3. So since we went down, that's down 3. So that's negative 3. And then we went from here, from this point over here, over to here. We had to go to the left 1, 2, 3, 4, 5, 6. So we went left 6. So that's negative 6. So our rise was negative 3 over negative 6, which again simplifies to 1/2. Because once again, a negative over a negative, that makes a positive, and 3/6 reduces to a half. So it doesn't matter which way you go when you're determining your slope. Okay? All right, let's find the slopes of these lines. Well, this first line right here, notice from going from the bottom point to the top point, our rise, if once again we're using rise over run, our rise was 1, 2, 3, 4, 5, 6. So our rise was 6. And our run, well, we didn't go any run. It was just all rise. So our run was 0. So if you type 6 divided by 0 in your calculator, you get an error. That's because you can't divide by 0. That's impossible. All right, this is undefined. And then the same thing over here. Once again, slope being rise over run. Here, we're all run. There was no rise at all. Okay, so here we went over 1, 2, 3, 4, 5, 6. And that once again reduces down to 0. Okay, 0 divided by 6 you can do. Okay, so notice that vertical lines have a slope that is undefined, while horizontal lines, such as this one, have slopes that are 0. In general, this probably would help you out to determine the general ways that slopes go. If you have a line that's rising, like this one is, if it's rising from left to right, it's going to have a positive slope. Okay? And we look at lines just like we read sentences. You always go from left to right. All right? And this line from left to right is going up. That's why we know that it's rising. Okay? It's going up. So that has a positive slope. This line is falling, is going down. So therefore it's a negative slope. This line has a slope of 0 because it's just there. And this line is a slope of undefined because it's vertical. There was a mnemonic device that I learned, well, not a mnemonic device, but a little um, way to remember the difference between a slope of 0 and the slope of undefined a while ago. Someone told me, well, picture these as ski slopes. If you were skiing on a hill that looked completely horizontal, you wouldn't go anywhere, nowhere at all. So that's a slope of 0. But if you were skiing on a slope that looked like this, that's not really a hill, it's like a cliff. So you would fall off and you probably wouldn't exist anymore. You would be undefined. All right, so that's how you can remember the difference between a horizontal line and its slope being 0 and a vertical line and its slope being undefined. All right, here I give you 2 points and I tell you to find the slope between those two. It's probably easier in this problem to use our slope formula, y2 minus y1 over x2 minus x1. I would always suggest that when you're doing the slope between 2 points that you, number one, write out the slope formula, and then number two, label your points. All right, let's label this one x1, y1, x2, y2. It doesn't matter which one you label x1 and y1 and x2 and y2, as long as you're consistent. If you make this x1, this has to be y1. Okay? You can't mix and match. You can't have an x1 right here and a y2 right here. That's not possible. All right? They have to match. So from there, you could just plug in your points. So we know y2 is 1. We know y1 is 5. We know x2 is 8. And we know x1 is 2. So now we can just simplify. 1 minus 5, that's negative 4. 8 minus 2, that's positive 6. So that reduces down to negative 2/3, which will be the slope of that line. And also we can tell that that line, this would be a line that's falling because it's a negative slope. All right, moving on. This table shows a linear relationship, find the slope. No matter what, if you have a line, any 2 points on a line will always give you the same slope. I'm going to go back a little bit. Let's go to this one. We said the slope of this line is 1/2. Any 2 points on this line would have given you the same slope. Like we use this point and this point. But there's more than those points on the graph. You have infinite points on a line. What if I used this point here and this point here? From here to here, we had to go up 1, right 2. So again, rise over run is 1/2. From here to here, we went up 1, right 2. Okay, so it doesn't really matter what points you pick when you're doing slope. That's the same thing here. They said that this table represents a linear relationship. So in other words, these are all points on the line. We have the ordered pair -2, 5, the ordered pair -1, 3, the ordered pair 0, 1, and the ordered pair 1, -1. You could pick any of those two. It's any 2 points and find the slope between them. I'm just going to go ahead and pick, let's say, the first one and the last one. All right, so I can label this x1, y1, x2, y2. My slope formula is y2 minus y1 over x2 minus x1. So I'll just plug them in. So y2 is -1 minus y1, which is 5, over my x2 is +1 minus my x1, which is -2. -1 minus 5, that's -6. 1 minus -2, well, minus a negative becomes a plus, so that's 3. That reduces down to -2. All right, and you would have gotten that, once again, if you used any 2 points. Any 2. Did not matter which 2 you used. All right, this one says find the slope of the line described by 2x plus 3y equals 12. Now, once again, we need to find, we need 2 points at least to do our slope. So we talked about this back in lesson 4.2. One of the easiest ways to do this problem is to get 2 points by using your intercepts. If I use my cover-up method here and find my x-intercept is going to be, well, 2 times what value gives me 12? 6. So that means that my x-intercept is a 0.60. I can do that same concept to find my y-intercept. Cover up my x. 3 times what value will give you 12? Well, that's 4. 3 times 4 gives you 12. So that's the 0.04. Now that I have those 2 points, I can find the slope between them. Once again, my slope formula, y2 minus y1 over x2 minus x1. So here's my x1, here's my y1, here's my x2, here's my y2. Once again, doesn't matter which one you label as which. Y2 is 4 in my example, minus y1 is 0. Over x2 is 0, minus x1 is 6 in this problem. 4 minus 0 is 4. 0 minus 6 is negative 6. That reduces down to negative 2/3. And there's my slope. Alright, hopefully this video has been helpful to you. Have a wonderful day.